this is the solution of the previous activity, so activity number 8, where you have to control Arduino from Telegram, so you can send some text on the LCD screen, and you can also choose the color for the RGB LED with just one command. So we have a few things to do. Let's start, as always, with the Arduino side, and let's initialize serial here with the baud rate, while not serial. Okay, that's pretty fast to do. And then we will need to initialize the LCD and the RGB. So let's create the defines. Define RGB red pin, which is 11. Define RGB green pin, which is 10. Let's not make a mistake this time on the blue. Blue pin, which is 9 and not 19, like I did before. And then define LCD RS pin. I'm gonna put the number just after. Define LCD E pin. Define LCD D4. So we have D4, D5, D6, D7, 5, 6, 7, with A4, A5, 2, 3, 4, and 5. Okay, you make sure they are correctly configured. We include the liquid crystal, but with a Y here, H, and then we create the liquid crystal here, so liquid crystal LCD. So the initialization is always the same. You can even copy paste the code from the previous lessons if you want to. So RSE D4, and then D5, D6, and D7. Okay, let's do LCD.begin 16 by 2, and let's also do the pin mode with RGB red to output, and then the same for the green, and the same for the blue. And we are done with initialization of the Arduino component. Now in the void loop, so I'm gonna remove that and I'm gonna do this again, okay, explaining it step by step. So in the void loop, well, we don't have any other thing to do than checking the serial. So if serial.available greater strictly than 0, we are going to read the command is equal to serial.read string until \n, and then we're gonna check if command is equal to, okay, let's start with the LCD. What command do we receive here and what command do we send here? So this command will contain first something that we can recognize, for example, print text, but then it's gonna contain something that we don't know yet from the Arduino side, okay? So instead of just checking the equality for the command, I'm gonna do if command dot starts with, and let's say that the command starts with print text, colon, and then we have the text. So if it starts with this, we are gonna do command dot remove. So we remove the first command, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we remove from 0 to 11. And we are left with the text to print, and let's do lcd.print command. And before we print the command, we could also, for example, do lcd.clear. Okay, and lcd.set cursor 0, 0. We clear, we come back to the beginning, we print the text. Okay, let's go to the next. So else if command dot starts with, now we have the set LED. Okay, so we check if it's a print text command or a set LED command. If this is the case, okay, before I forget, I'm just gonna add else where we do nothing for now. And well, I will add a best practice in the final project, okay, for this else that you're gonna see later, one thing at a time. So if we have the command that starts with set LED, then 1, 2, 3, 4, 5, 6, 7, 8, we do command dot remove 0, 8, and then we get each color. So int red is equal to command dot substring from 0 to 3 and dot to int. Okay, you can put this as a help if you want to count. Let's say we have this. So 0, 1, 2, 3, and then 4, 5, 6, 7. So we do int green. Of course, it's important that when you send the command, you respect the order, okay? Red, green, blue. Command dot substring from 4 to 7. So we just ignore the comma to int. Int blue is equal to command dot substring. Okay, if this is 7, then this is 8. We put 8, and we don't need to provide the end if we just want to go until the end. Okay, so we just read the 3 last characters. To int, okay, to int because we have a string, we need to convert to int, so we can use in analog write. Analog write with the red first, and we give red color. And let's do the same for the green and the blue. Green with green and blue with the blue we just got. Okay, let's remove that. And I think our program is complete. Let's just try it. Okay, let's upload the code. Activity 8. And let's try. Okay, we first have an error here. Yes, because I forgot. So this is quite a sneaky error here. I forgot the parentheses because we open parentheses, we open one, so we have to close 2. And of course the same here. Load. Okay, the compiling works, now the uploading should work as well. And well, let's try something here. So I'm gonna open the serial monitor and let's send some command. For example, we want to print something, so print text with, let's put a space here, for example, hello world. You can see we have hello world on the screen here, and we have, well, we have actually one space before, because you can see we have added one space. So everything that we have after print text colon is gonna be printed. Let's change the string with A, B, C, D, E, for example. You can see now everything has been cleared. We start back at the beginning and we print A, B, C, D, E. If I do RGB, no, actually it's set LED with, let's put 200, and then 0, and then 180. Okay, we have a purple here, a purple color, so it's correctly working. Okay, so now that we know the Arduino code is working, let's write the code so that we can actually control this from Telegram. Okay, so on the Raspberry Pi, let's first connect to serial, and I'm gonna, here, I'm not gonna write the code entirely. I'm going to use the code we did previously with the retry, okay? So like this, and then this. So we try to connect to serial, and then we wait for 3 seconds, serial OK, and we have this infinite loop running inside a try except block. And now I am going to add, so I'm just going to leave it there. I'm just going to comment that. Okay, this is a comment. And I'm going to add the Telegram functionality. So from telegram.ext, we are going to import this time updater and command handler. I'm going to get the token like we did before. So I'm just going to get the token like this. So for example here. And then we are going to create not a bot object, but an updater. So updater is equal to updater with token equals Telegram token. Okay, so we do that after we have correctly initialized the serial here. We add a dispatcher, which is updater.dispatcher. And then we are going to add some callbacks. Okay, so let's add the callbacks right here before this code. So def, let's say we have a start handler. Okay, let's always create a start handler. Update context. And in the start handler, we do context.bot.send message with chat ID is equal to update dot effective chat dot ID, and text is equal to, let's say, hello, or maybe just welcome. Okay, we have the start handler. Then we create a, let's name it LCD handler. Okay, update context. And what do we do? When we receive a command from the LCD, we are going to send that command to the Raspberry Pi. So how to get the text? The text is update.message.text. I'm gonna remove that now. And now the string to send, so the command is gonna be equal to print text, okay, because we need to send print text here, and then plus text, and then plus \n, and we do say dot write command dot encode with UTF-8. Okay, and also what we could do is just send back a message to our bot to confirm that we have done the operation. Okay, context.bot.send. So actually that's going to be the same as here. And the text, let's just send OK. All right, now we have def RGB handler, so you just name it as you want. That's just a function, update context. But as you can see, I usually put handler. Okay, I put the name of the command and then handler, so that it's easier to navigate the code. Okay, we have the text, which is also update.message.text. We create the command is equal to, so the command this time is set LED with colon, and we expect the user from Telegram to give us the correct format, okay, for the command we're gonna send. So this, I'm just gonna leave it like that, but as an improvement, what you could do is to validate the data here also, and then try to find another way to send data with a less strict format. Plus \n at the end, let's not forget that. And then, well, we just do the same thing here. We write the command and we send back a message to the chat. Okay, now let's not forget to add those handlers. So dispatcher.add handler, command handler, and we have, so the keyword start is going to go with start handler, and then let's add another 2 of those. We will have the command lcd, which is going to go with the lcd handler. So you don't necessarily have to put the same command here and the same name for the function. It is not linked. Okay, I just use it for simplicity, and the RGB command for the RGB handler. Okay, after we have all the commands that are ready to be dispatched, we do updater.start polling, and the last thing is that when we actually close the program, we do closing serial, and we then do print stopping Telegram data, okay, where we have to wait a few seconds, and we do updater.stop. Okay, so we start and we stop. All right, let's try this code. So we have written more than 50 lines of code, and let's just try, let's see if it works. Activity 8. So let's see what we get here. Successfully connected to serial. Okay. Now let's open Telegram and let's just send some comments. So lcd hello. Let's see what we get. Okay, you can see on the screen we have not just hello, but we have /lcd space hello. So we need to come back to our program, and well, here we haven't tested. Okay, so it was kind of luck if it was going to work or not. But when you see that we get update.message.text, we get the complete text, okay, even with the command and the space. So we need to remove that before we send it, of course. So what we can do is actually something similar that we did here under Arduino, is to remove the first n characters. Okay, let's do that. It's gonna be simpler. So here we receive. So we receive /lcd space and then command. So we have 1, 2, 3, 4, 5 characters to remove. So what we can do is just do 5 and colon and bracket. So the string is also an array of characters. Okay, so if you do that, you're gonna remove the first 5 characters. Okay, let's run again. And once it is connected, let's send the same lcd hello. And you can see now we have hello on the screen. And so I'm going to come back to the program to change, of course, here for the RGB handler. So for the RGB handler, we have /RGB and then command. So we have also 1, 2, 3, 4, 5 characters to remove. So we do this 5 colon bracket to take everything after the 5th character. Let's run that. Serial OK. And let's try with /RGB. Let's give the same color as before, 200, 0, 180, and let's see what we get. You can see now the here RGB is purple. Okay, let's print some text. LCD, it works, and well, it correctly works. We can control the Arduino components from Telegram chat. All right, and this is the end of this activity.